Hi, my name is Ashley, and I'm an explainer at the National Air and Space Museum How Things Fly Gallery, and today we're going to learn about rocket engines. Over here, I have a model of the Saturn V rocket, which was used to launch the Apollo astronauts in 1969. Now, behind me, I have a real F1 engine. Each F1 engine was capable of producing about 1.5 million pounds of thrust. Now, this model of the Saturn V rocket has 5 F1 engines. So, calculating that, you have about 7.5 million pounds of thrust produced by this rocket. As you can see, a tremendous amount of thrust is needed that can't be obtained from a propeller or jet engine. In addition, propeller or jet engines don't work in the vacuum of space. Rockets are special though. They carry their own oxygen or other oxidizers on board with them. So now let's learn about how a rocket engine actually works. So we have the fuel and we have the oxidizers. Now they ignite inside of the combustion chamber, and then all of that is let out as exhaust coming out of each one of the 5 F1 rocket engines. Now, inside of the engine we have a pressure difference. Because of that, our rocket's going to shoot upwards. And according to Newton's third law of motion, for every action there has to be an equal and opposite reaction, which is the exhaust moving downwards. Now, there are 3 main types of rockets: liquid, solid, and gas. So today we're going to launch off our own gas rocket. Here, I have a cartridge that's filled with compressed carbon dioxide gas. I'm going to poke a small hole on this end of the cartridge so that all my carbon dioxide gas is going to spew out this way. So if my gas is spewing out that way, which way should my rocket go? That way, right? So let's see what happens. Now, according to NASA standards, we're going to have a countdown starting from 5, 4, 3, 2, 1. And that's how rockets generate thrust.